Yes, friends, so we are discussing the Bayes Theorem. Okay, now questions based on Bayes Theorem. I completed up to second question. Okay, question number 2 I have completed. First was definition based on definition of Bayes Theorem. What is Bayes Theorem and how it is defined? What are the posterior probability? Why this is known as posterior probability? Why this is known as inverse probability? Why this is known as revised probability? So all that I have described in detail. And again, whenever there is requirement of this, I'll just clarify that what is Bayes Theorem, how Bayes Theorem is applied here. Okay, and Bayes Theorem, as I told you, is known as posterior probability. Posterior probability means whatever the prior information is given, prior probabilities are given. Based on the prior information of prior probabilities and likelihood probabilities, we have to find out what is the posterior probability. A posterior probability, when calculated, this is known as Bayes Theorem. Bayes Theorem gives us posterior probabilities, which I have already clarified. Now question number 3 I am taking. Question 3 says, a certain production, I have written down here, it says a certain production house or process, items are 10% defective. In a certain production process, always there is 10% items are defective. Okay, in that production process, 10% of the items are defective. Okay, now each item is inspected before being supplied to the customers. Every item is being inspected, okay, before being supplied to the customers, but the inspector incorrectly classifies. But what does inspector who inspects the items, he does it wrongly. What does he say? What does he did? Or he did what does he did? Okay, so he did, but the inspector incorrectly classifies an item 10% of the time or 10% of the items. So 10% of the items incorrectly classifies, either as incorrect or good. Okay, it may be good here, 10% of them, those items are classified by him as good, but they are not good. Or as bad, 10% of them are defective, but they are not defective. Incorrectly classify them. Only items classified as good are supplied naturally. So if the inspector correctly says that they are good, after inspection he says that these items are good, then they will be supplied. But 10% of the time, this is 10% of the time he wrongly picks up. This is not items, 10% of the time here. 10% of the time. What does it mean? That whatever is incorrectly classified them, 10% of the time is, it is 100% if he says they are good but not good, 10% they are defective. Okay, that is how 10% are defective again. Okay, but 90% are good, or 90% are defective and 10% are good. In that way, he is classifying incorrectly classified them. Now it says that only items classified as good are supplied. Okay, so 820 items in all are supplied. Now we have to find out that how many items were, how many of them are expected to be defective. So defective items, how many out of this 820, we have to find out that how many items are defective. That we have to calculate. First we will calculate that what is the probability of defective items. So it says 1 upon 10. Now inspector also classify them as 10%. Defective items are 1 upon 10 into 1 upon 10. Right? This is this kind of process. This we will keep in the numerator. 1 upon 10 into 1 upon 10. This is incorrect items or defective items, because 10% are already defective. So let me take the event. There are two events here, two kind of activities are here. First is defective items. Defective items, inspector also classify them as good, but they are defective items. Right? 10%, 10%, so 1 upon 10 into 1 upon 10. And then okay, so effective items, not defective, but non-defective items are how many? 90%, so 9 upon 10. 9 upon 10 are the non-defective items, right? And non-defective items, the inspector also clarified them 10% are defective, again 9 upon 10 into 9 upon 10, they are good, because inspector also clarifies them as good. Now let me take the probabilities. What we have to assume here, so here the event A, let me take, this is event A here. Event A denotes that items are defective. Items are defective. Items are defective. The probability of A here and inspector also, there are two cases here. There are two types of cases. Let me take here. Here two cases are there. Two cases are here. Here two cases are there. What are the two cases? First is defective items, and inspector also clarifies them as defective. Okay. Here are two cases. Here two cases are there. First is here the event A denotes that items are defective, and inspector also declares them good, because he is incorrectly saying good, but he says good, those 10%. Inspector also declares them good. So this is equal to 1 upon 10 into 1 upon 10. That is 1 upon 100. The defective items, right? Defective, this is defective probability, we can say. Defective possibility or probability. This is defective probability. What the point? Secondly, second case is that event B denotes non-defective items. Non-defective items, and its probability, chances, and its probability is 9 upon 10. Why? Because 1 upon 10 is defective and 9 upon 10 will be non-defective. And inspector also declares that. And inspector also declares them non-defective or good. Also declares them good. Okay, so that is 9 upon 10 into 9 upon 10. That means 81 upon 100. These are the good items. Now we have to find out that what is the probability. Now this sum of these two probabilities. Okay, so this probability is, we can say that this probability plus this probability will come in the denominator, sum of these two, and this will come in the numerator. So out of 820, therefore probability of how many items will be defective. So solution I am finding out here. The solution here. So the number of, let me show the number of defective items out of 820 is given as 820 into 1 upon 10. This is defective. We are finding out how many items of them are defective. This defective probability will come in the numerator divided by sum of these two, 1 upon 10 plus this 9 upon 10 into 9 upon 10. Okay, because the whole probability, sum of all the possibilities are kept, or all outcomes, negative, positive, they are kept in the denominator. only defective probability we will keep in the numerator, this upon this. That will give us the number of items which are defective. How many items are defective? Let me now calculate this. So defective items. So defective items out of 820 is, let me take this as 820. This is here 1 upon 100 divided by, this is 1 plus 9, 9 9 is 81, 81 plus 1 82 upon 100. So this 100 cancel out, 80 and this 10 times, only 10 items are here, equal to 10. So only 10 items are defective. Only 10 items are defective. Okay, so here we have to just find out that how many defective items are there. Because this was the defective percentage, 10% were defective, so 1.10 by the probability of being defective. Inspector also tells them defect 10% of them. He incorrectly classified that they are good but they are defective. 1.10, 10% is also defective. 10, 1.10 to 1.10, these are the defective probability of defective items. Okay, so this is prior probability of A into probability of B upon A, we can say. Okay, probability of B upon A, probability of A into probability of B upon A, or because these are the defective items, divided by probability of A into probability of B upon A plus probability of, now in this case we are taking A, and this is suppose A1, A2. This is A1 here, A1 even, probability of A1 into probability of B upon A1. B is the event that the product are defective items. So defective items we have to select here. Okay, so this is number 10. 10 answer is there. So only 10 items out of these 820 are defective items. What we did was just we calculated certain production process items are 10% defective. We just calculated how many items or what percent of item, probability of item being defective is 1.10. Now each item is inspected before being supplied to customers, but the inspector incorrectly classifies an item 10% of the items. 10% of the items incorrectly classified as defective and non-defective is good. Okay, so here defective items again 10% he says defective. So this 1.10 again defective, probability of defective items is 1.10 into 1.10. So this is first case. Second case is that how many are non-defective, because 10% are defective, so 9 upon 10 or 90%, we can say 90%, 90 upon 100 means 9 upon 10. So 9 upon 10% are non-defective. The inspector also declares that 9 upon 10% are non-defective again. This is also tells why that 10% are defective. Incorrectly he classified them as defective or good. He said good but they are defective. So incorrect means just reverse of that. 10% are good, it says. It is good here, 10%, but they are incorrectly declared by the inspector. So this is how 10% are. Again, so 1.10, 1.10. Here the defective percentage probability. That we kept in the numerator. Okay, and sum of these two, defective and non-defective, probability of these two, sum of them, as we always say in the, this is posterior probability, we have calculated 10% for 10 items out of 820 were defective. Okay, with the help of this decision making process, which is known as Bayes Theorem, we have calculated that out of 820 which were supplied to the customers, only 10 were defective items. Okay, so this is question number 3. We have completed. Let me take now question number 4. What is question number 4 say? Let me take question number 4. What does it say? Now question 4, 5 and 6. Only 6 questions are taken here because these are the wording, word problems. More words are given than a problem, because this problem covers more words. Because of that, the space has been occupied by only 6 questions. Alright, so 6 questions are there. only 5 questions because one was definition, etc. And the other 5 questions are there. This is question number 3 we have completed. 10 items were defective items. Now let me take question number 4. Now question number 4, what did it say? What is given to us? Now question number 4 says, we are given here that a box 1 contains 3 defective items. It is given to us. It says box 1 contains 3 defective and 7 non-defective. Yeah, 3 defective and 7 non-defective. What? Non-defective balls, right? Non-defective balls. Alright, then, and box, let me take box 2. Box 2 contains 1 defective. Yeah, box 2 contains 1 defective and 9 non-defective. Okay, let me take this, and 9 non-defective. Okay, let us take next thing, non-defective balls. Non-defective. These are 2 boxes which are defined in this way. So 2 boxes. First box have 3 defective, 7 non-defective. Second box has 1 defective and 9 non-defective balls inside it. Now what does it say? Then it says that one box we selected box, or one box is selected. We select a box. We select a box at random. A box at random. We select a box at random and then draw one ball and then draw one ball at random from the box. Alright, from the box. One ball is drawn randomly from the box. One box is selected. And then we are drawing one ball. What does it say then? Now it says what is the probability. Then there are some parts here, C parts, 3 parts are there. Okay, from the box, then find first thing. So then we have to find out, let me write it here. Find then. First A part says what is the probability of drawing a non-defective ball. Part A says the probability, find the probability of what the probability of drawing a non-defective ball. Drawing a non-defective ball. Alright, non-defective ball. This is first part. B part says what is the probability of drawing a defective ball. The probability of, second part says find the probability of drawing a defective ball. Drawing a defective ball. Alright. C part says that what is the probability that the box 1 was chosen given a defective ball is drawn and defective ball is being drawn. So the probability that box 1 drawn or is selected and defective ball is drawn, is selected, and okay, box 1 was chosen or selected and given a defective ball is drawn, and a defective ball is drawn. That is given to us that a defective ball is being drawn. Now, is it from box number 1? What is the probability of that? And a defective ball is it drawn? So what is the probability of that? There are 3 cases here. Now let me take this from here. Solution. Let me find the solution. Now try to understand this question. What does it say? Let's say the probability of drawing a defective ball. So first of all, a ball, there are 2 boxes. So one box is selected at random. The probability of that is 1.2, 1.2. Both of them are. Okay, so probability of selecting, let B1 be the event. B1 be the event. Box 1 is selected. Box 1 is selected or is chosen. Selected or chosen here, but given is chosen. And B2 be the event. The box 2 is chosen. The box 2 is chosen. So what is the probability of that box being chosen? So let me, the probability of drawing non-defective ball. Okay. So first, the probability, this is prior probability. Probability of B1 is 1.2 equal to probability of B2 also. Okay, box 1, box 2. Both have the same probability, 1.2, 1.2. Now, what is the probability that from box 1, B1, that event A, that A is the event, that ball is defective. Okay, that probability of D, defective ball, non-defective ball, we can say. So probability of defective ball, let me take D. The probability of D being defective ball, that means this will be probability of, first is box 1 and a defective ball, plus second case can be, this is probability of defective ball completely. We have to just find in both ways. Probability of box 2 and defective ball and defective ball. What is this probability? Let me rub this. This is the first part here. Defective ball. The first part was saying what is the probability? What is the probability of drawing a non-defective? Okay, so this is defective, and non-defective. And let me take probability of ND. This is non-defective. Probability of non-defective will be probability of again box 1. These are 2 cases here. This is defective from both the boxes. Possibility are there that defective ball is selected from box 1, box 2. This will be kept in the denominator, right? In box 1, and then non-defective ball. Okay, this is non-defective ball from box 1 plus probability of box 2 and non-defective ball. Non-defective ball from box number 2. What is that? So in first case, this is 1.2 box selected into, what is the defective ball? In the first box, 3 balls were defective, so 3 upon 10. So total is 10, 3 upon 10. So this is 1 upon 2 into first one defective ball. This is probability of D. This implies the probability of D defective ball we are calculating. So 3 upon 10 here, plus this is 1.2 into the second one defective ball, 9 non-defective. In the second box, 1 defective ball. So this is 1 upon 10 here. So sum of these two will be 3 upon 20 plus 1 upon 20, 4 upon 20. This is 4 upon 20. This is, let me take 1. maybe 1.5, and probability of non-defective, as this I have described here, non-defective. This is second equation we took here. Let me take this second equation. This is the first equation. So from second equation, probability of box 1 non-defective ball, box 1 selected is 1.2 probability into non-defective ball 7 upon 10. In the box 1, 7 are non-defective, 7 upon 10. For total balls are 7 plus 3, 10. Denominator 10 and numerator is 7 out of 10 are non-defective balls. Plus box number 2 is selected 1.2 probability into how many non-defective balls? 9 upon 10. So what is this probability of non-defective balls? This is how much? 1.2 into this 7 upon 20 and 9 upon 20. So this is 16 upon 20. 10 into 220. 16 upon 20 I am writing here, no problem. Okay, so this is probability of non-defective balls. Now this will come in the denominator. So non-defective balls are this. Defective balls probability is this. Probability of defective balls. So first and second, I think these two parts A and B are calculated. Just we have to find out defective balls, non-defective. These are the prior information. Because this whole information is given to this is prior probability. This is known as prior probability. Probability of defective balls, probability of non-defective balls. Okay. Now it says that what is the probability that box C part? What is the probability that box 1 was chosen? Now this is known as posterior probability of Bayes theorem. Here we will apply the Bayes theorem in the part C. Okay, and up to this we have just calculated what the probability of defective balls, what the probability of non-defective balls. Now probability of defective balls is 4 upon 20. So this will be kept in the denominator because out of these two boxes we have calculated the sum of all the defective balls probability 4 upon 20 in the denominator. In numerator we will get one balls probability. I mean the first box selected, and then the defective balls probability is 3 upon 10. 3 upon 10 in the first box. So what is the probability? Let me find out this. These are two parts we have solved, A and B. Now what is C part here? Now C part says that part C here. So probability of drawing a defective ball, from the box number 1 chosen. This is part C. What is this probability? This probability of selecting a ball box B1 out of box B1. What is the defective ball? So D upon, we can say this is D upon B1, defective ball upon E, or this we can say defective ball the D1, or just say B1, box 1. This is equal to, okay, combination of these two, I mean intersection of these two divided by probability of D. So this was here probability of D, or let me write here, this is 1 upon 2 into 3 upon 10 defective balls, box 1 is selected, and this 3 upon 10 can be said as probability of D by B, B1. D by B means box 1 upon, or sorry, from box 1 we are selecting, this is probability of D into probability of B1 by D, or this is, I could write that upon probability of D defective balls. So, or this could be written as probability of D, right, this is probability of defective balls, or sorry, this is box 1, probability of D by probability of D into probability of B1 by D, probability of B1 by D. Defective is the main event. Okay, so box 1 is selecting, or we could say B1 upon D. So here box B1 is selected, and then we are doing this question. So this 1 upon 2 into this value is